Okay, I think we'll start. And as I said, if you have questions, feel free to set them on chat. Welcome to Troubleshooting Drivers with WinDriver on Linux. I am Daniel Bar. I'm the Technical Customer Success Manager at WinDriver. If you ever reached us on the support center, we've probably talked before. Let's go. So this is one of a series of webinars. Yesterday we had troubleshooting drivers with Windows, on Windows with WinDriver. And the next webinars will be in 2 weeks, the introduction series. On October, we will have a version launch, 16.2, which will include significant improvements and changes. In terms of INF, which is less relevant for Linux, but also for coding. We are planning to add a cool feature for making the coding easier on the wizard. So I really recommend you to stay tuned. On December, we will have distribution webinars dedicated for distributing with Windows and Linux, again, two separated webinars. And we're planning to host workshops about kernel plugins and interrupt handling, which we've been asked for by clients. I will add 2 links to the chat now. One is our LinkedIn page, where I really recommend you to follow and see the content that is published there. It's professional content and updates regarding the company, future events, and our newsletter subscription link. Subscribe to the newsletter and you will be informed of events and updates and notifications from us. Okay, so let's start. The webinar is essentially can be split into 3 parts. The troubleshooting foundations, where we go over tools, relevant tools for Linux, methodologies, how to troubleshoot, and development levels. We then get a quick overview regarding WinDriver in order to understand the mechanism, the common issues, and troubleshooting tools, which will help us understand better the behavior of WinDriver on Linux. And then we will see case studies, interesting case studies for issues involving DMA, interrupt handling, and device opening. So when we're talking about Linux, there are not too many troubleshooting tools as there are on Windows. Microsoft developed a bunch of in-house tools in order to monitor processes and kernel plugins and everything, so you can get a really clear picture. It is much simpler on Linux, and it makes the debugging process, let's say, easier to track because there are not too many logs options. But we need to be more aware of what the log means and what they are indicating. The first tool on this list is not related to Linux. It is WinDriver utility, and it is regarding it's the WD debug. It's in the util folder of WinDriver. This tool is actually monitoring WinDriver or your driver using the kernel module. All the kernel communication and functions that are running on your app, on your WinDriver, it helps to monitor the processes and the behavior of the apps, making for us the search for the root cause much easier. I will elaborate on it further, but I will only say that if you ever reached us with an issue on our support center, we will probably ask you for the WD debug because it gives us a hint of what is going on in the backstage of the app or WinDriver in case of errors. dmessage is Linux command that displays kernel messages and providing a record of the system's activities and events. It is, I think, the best tool for troubleshooting because it offers insights into the hardware and software interactions, errors, and device statuses. By analyzing these messages, you can identify issues, track down causes of problems, and make informed decisions to resolve them effectively. One thing I like about the D message is, first of all, it is very elaborate, and you get notified on issues and errors. So sometimes all you have to do is to look for the error or failure on the D message. If it's Vim, I will talk about Vim or VS Code, and see the relevant log and what went wrong. The -W makes it to run in the background. So if you only print the message, you will see the logs of what happened so far from the boot. And if you print the message W, you will see the log. You will see the log in the background in a separate terminal, and it will monitor everything that happens between the hardware and the software. I mean the kernel mode. So the LSPCI, when we talk about devices and installations, of course we need to see a list of the devices. So this is what we have the LSPCI and LSUSB for. These are Linux commands that list information about devices connected to the PCI and USB buses. They are essential for troubleshooting as they help users identify hardware components, their drivers, and their current status. By using these commands, you can quickly gather details about connected devices, aiding in diagnosing compatibility issues, driver problems, and hardware configuration. So sometimes we cannot find the device, or we see that it connects, or we can see the device, but we cannot access it. If we need to search and find more information regarding the device status, LSPCI or LSUSB, for PCI and USB respectively, this is one of the most informative commands regarding when talking about devices statuses. The -VV, it means verbose. You can, I think, go up until 3 verboses, so V or VV or triple V. And you can see everything there. You can see what kernel modules are attached to this device. You can see the status. There's a lot of info there. So both DMessage and LSPCI or LSUSB are highly recommended tools to get deeply familiar with. Run it even if you don't have an issue. Just see the logs, see what it prints, and what you can learn from them. So when you have an issue, you will know what to look for and what information you can get from these logs. Just a general information. On Windows, so now we have logs and we need to open them and get an overview and look for places, look for errors. We don't have too many tools, or let's say sophisticated tools, to do so on Linux. We are using Notepad++ on Windows, but this product is not available for Linux. So we recommend using Visual Studio Code. I will show later how it is done, and also Vim. Vim, I guess you all know Vim, not the most user-friendly application, but it's working. So if you Vim this, you will have 2 logs, and I will get to that in the next slide, and you will be able to regress, to compare the both and look for what went wrong with what place or time. So these are the tools I recommend focusing, and find your favorite ones and learn how to operate them. So the methodology is basically split into 3. Sometimes, it's harder to figure out what's causing the problem than to fix it, because we are working in such a complex environment with a lot of moving parts. We have the hardware, the card, the kernel version, the WinDriver version, the operating system version. a lot of things, changes, updates, things that even are not we are not in control of. And when something breaks, we need to understand where it happened. So what we need to do is eventually to eliminate the options of what went wrong, and this is where this is what the methodology is aiming for. So each issue, again, it depends on the issue, and we will see in the case studies what exactly I mean, but each issue has its logs, and this is what it is important to understand and learn about your troubleshooting tools, so you will know where to look for. So in order to start solving the problem, we need to look at the different parts of the computer or the process, from the physical part to the software, and narrow down the possibilities. If we have only a single example or a case, let's say we got a failure in the configuration space, then we need to open a log and see that the D message, and you will see there that the configuration space, for example, is inaccessible. This is an easy part because the log indicates pretty straightforwardly what the issue is. The more complex cases are breaking cases, where, let's say, you updated your kernel version, for example, for security reasons, and then your driver stopped working because of incompatibility. How do we know what went wrong? Or a card you have worked on one PC and is not working on another PC. And we need to start to understand what went wrong. Again, it is not that clear because perhaps it's incompatibility with the CPU or the motherboard or the kernel version of the specific PC. So the whole point of this slide is to emphasize how complex is the environment we are dealing with, and we need to understand it. And once we understand all the moving parts, we can start narrowing down the options for investigation. So as I said, the diff and regress option, let's say I took the logs from, in a case where I had the card working on PC1 and it is not working on PC2, I took the same log from PC1 and PC2 and we diff and regress them using Visual Studio Code or Vim. This is Visual Studio. You have a compare selected option, and then you can see both logs, one on the side of the another. And it makes the troubleshooting much easier because you can see even in the chronological time what went wrong. So this is our recommendation and the methodology we're working by here. This is just, let's say, a pretty straightforward scheme of what we recommend to do. If it works, log it. If it doesn't work, log it, and diff and regress. As I said, operating system, different cards, different PCs, different WinDriver version, different kernels. Log everything, and then it will be much easier to investigate later what went wrong. I also recommend, we ask for logs almost on every ticket, and clients send us the logs. I recommend you to enter the logs, to look at the logs and see what they print and what information they provide. Perhaps you can find the failure yourself, not to save me time, but for you to be more familiar with these tools. And maybe it will save you time for waiting for us, although we're responsive, and maybe learn something new along the way. So open the logs and take a look and see what it says. A lot of times it is pretty straightforward. You can see where the error or the issue relies, and then we can help fixing the issue rather than spending time on finding it. This is another slide that only emphasizes how complex our field is. the driver development field. So we have the hardware level where, let's say, you open the interrupts, turning them on and off on the card itself. You have the memory ranges, the bandwidth, the bit stream, the header types, configuration space, everything that relies on the hardware. So let's say, and we have the kernel mode, which includes the kernel vision, the kernel debugging, the kernel logs, and the user mode. Let's say, for example, you can read write from the user mode, perform DMAs, manage the interrupt handler, and allocate buffers. So let's say, for example, you got an error regarding the configuration space. Where do we start? Or for example, for the memory range, you got an error, memory range out of reach. Where do we start? Is it a user mode issue? Our kernel version is old and it can't grasp the range of the memory, or is it a hardware issue and the memory ranges are malfigured or malformed? Every time we see, even if we get a straightforward notice or message regarding a specific component, we need to understand better where does the issue takes place, where it relies. Maybe we try to read or write to the wrong memory range, hence we get that error. So again, this is only to emphasize the complexity of this field. Now let's have a quick overview on WinDriver. I don't know how many of you used it before, but WinDriver is an easy user mode driver development toolkit. You can automatically generate driver code in different languages, .NET, Python. You can, one moment, Java, Visual Basic. So you can develop drivers in different languages. We support any USB or PCI device regardless of the manufacturer. And we have enhanced support for specific chipsets from Altera, Xilinx, and Lattice, which are examples that our team built on top of specific devices from these companies. And you can get inspired by these samples, and maybe it will make your life easier when developing a driver for these specific manufacturers. It also you will need to modify it. You will need to configure it as per your current device, as these are all samples. But this is what we call enhanced support for the specific chipset. We also have working samples for interrupt handlers. It's called PCI/USB diagonal. We'll talk about them later. So before we talk about the case studies, we need to understand better how WinDriver works, what's the mechanism. So the I think most significant advantage of WinDriver is the working from the user mode. There is no need to work on the kernel mode or troubleshoot the kernel, which can be risky and messy sometimes. Everything takes place on the user mode, the reading, the writing, the interrupt handling, and the debugging also. So WinDriver, on your app, you are calling WinDriver API, which is very elaborate on our documentation. Different functions, WD, interrupt enablement, and device opening, and performing DMA. We have all the functions on this API, which you write, which you call to these functions on your user app. This API is connected to WinDriver kernel module that sits in the kernel mode, and essentially is executing these commands or these processes on your hardware. So as I said, everything is taking place on the user mode. It's an automated process and generated code. there is no hassle in building the code from scratch. You simply connect your device, choosing it from the list, and we will generate a code for you to start working with. And we'll also have an enhancement in the next version that we will identify more devices, and the view will be much user-friendly. You can perform advanced operations like DNA, transactions and transfers, interrupt handling. You can also use kernel plugins, which is taking a bulk of code from the user mode and put it on the kernel mode, and then by that save time and calculation time and resources. And it's we have the cross-platform compatibility. What does that mean? You can build your driver using CMake on different platforms, Windows, Linux. We support both Windows and Linux, so you can have both 2 licenses, one for Linux, one for Windows, and distribute your driver on a cross-platform. Let's talk about our debugging tool. As I said, we have the debugger. This is a GUI application. You can see here how it looks like. All the successful processes are painted in green, are outlined in green, and the failures are marked in red. You can see the functions that are being used currently, and some functions are clickable, and it leads to our documentation. So if you click on that on the debugger, it will take you to the website, to our documentation, and you can see what this function does, how it should be operated and built and executed. So it is very convenient. It got a new face recently, so I find it much nicer and user-friendly in order to comprehend what's going on the kernel mode. You can change the status, of course, choose the sections to be monitored, and change the driver name to your driver name. So if your driver name, for example, is webcam, because you develop a webcam, you can change the name here, and it will monitor the webcam operation. So you can monitor not only WinDriver, but your app as well, your driver as well. What most important is to make sure that the kernel module has been uploaded and enabled. So the WD debug will find it. You can choose the level of the investigation of the logs. We always recommend trace, and you can send a debug message to the operating system kernel debugger, which in Linux is the dmessage. So everything will be in one place. You can see it here, but you can also send the logs to the dmessage and have everything in one place. So as I said, in order to log your driver, you need to make sure that the kernel module of your driver was installed and enabled. This is what we have. Why we have the WD reg for. It's a dynamic loader of drivers, and it replaces the slower manual process. So all you have to do, it's in the util folder as well of WinDriver. You do not need to start, ls mode and everything and start working with the modules. You can load the modules via the util folders of WinDriver, and load and download. You can read more about this tool on chapter 16 on our documentation. But this is yet another tool that makes working on Linux and even troubleshooting much easier to load and unload kernel modules. The third tool I want to talk about is the PCI and USB diag, which are essentially working apps. And it sounds very trivial. What's the big news about working apps? So the fact that these are verified working apps enables to troubleshoot your app or your device. And what do I mean by that? First of all, let's say that you have connected your device, but you're unable to open it with your generated app or your driver. Then what we recommend is going to the PCI diag or USB diag, depends on your device, and try accessing it with these apps. What it will give us is an indication of what went wrong where. Because if it is working on a PCI or USB diag, that means that probably something on the code is not right, and then, hence you are not able to access your device. However, if you are not able to access the devices here via USB or PCI diag, probably something is not right with the card or the or Linux, and we need to better understand why. Again, the message would be my first choice. But this is like a breaking point of, you can say from this point, I know that the issue is on my app, and from this point, I know that the issue is not on my app and perhaps something on Linux. Then you can look for it on the LSPCI or LSUSB and then troubleshoot it from there. Another advantage of these examples, which are not related to troubleshooting, is the fact that they are working examples of interrupt handling and interrupt functions. So if you want to know how to operate the interrupt function, you can enter the PCI diag sample source code and see there how it is, how it was assembled, how it was formed and created, and again, it makes life much easier once you have a working example, and not all you need to do is modify and change the things in accordance with your device. So I'll go over WinDriver development steps and common issues that we are encountering, and then we will see a few case studies, interesting case studies. So the first one is an unloaded kernel module. We have a case study just for that. A lot of times, it's tricky. After the installation, we want the app to work, and then it's not working because the kernel module was not enabled or installed. A very common issue. This is why we have the WDREG tool. The error you will get is probably invalid handle. I don't know if you're familiar with it, but this issue is related to the kernel module. Mostly previous versions interferences. I will talk about upgrading WinDriver. Missing files and architecture incompatibility, which means 32 version installed on 64 architecture and vice versa. We encountered an issue of unrecognized devices on the wizard, and we talked about how we should start addressing this issue. Memory range issues and license issues. If you have questions regarding licenses and how to work with them, contact me and I will send you a guide I've created. And it is very elaborate on what needs to be updated where and how everything works essentially. We also get issue when clients compile their app. One of the I think most common errors are regarding removed includes and headers on the top of each document. We always recommend working with our generated app and not, take only parts of our code, because then you can miss important things like headers, and then it will not work. So working according to the documentation and best practices can solve a lot of issues here. Missing dependencies, also something Linux is famous of, and 32 and 64 compilation that requires preprocessor definitions to be specifically defined. You can find it on our documentation if you're interested. We have a dedicated sub-chapter for it. Invalid handles, crashings, DMA limitation, interrupt handlings are part of the user application errors we commonly receive. Not too commonly, but more common. And I will talk about the distribution part. We have an good documentation how you should distribute, and you need to modify a few things when distributing. But if you're not working according to the best practice, you will have errors. So let's start and talk about case studies. Some of them are really, really interesting. So the first one, as I said, is you build your app and you want to run it and see how it goes, how it functions. So you go sudo and opening your app, which in this case is called the test. And it says fail to initialize the test library, invalid handle. In this case, 99% of the kernel module is not updated. It's not uploaded. It's not enabled. So what we recommend to do is load the kernel module. You can look for it in the ls mode, and if it is not there, then use the wdrag utility in order to load it. If the kernel module is there, then perhaps the rename driver on the generated code was not updated properly. I'll explain it. When you generate your code, you get default driver name and driver license on the generated code. Because we don't know your driver name and your distribution license. So both of these should be coded and updated in the lib.c file. You can find it on every project code on line 92, 97 and 92, if I remember correctly. When that doesn't being updated, then it won't work, because on the code itself, it does not looking for the particular kernel module. And again, this is related to kernel module. So if the kernel module is loaded and everything looks okay, perhaps you forgot to update the rename driver name on the lib.c code file. The second example for troubleshooting would be unrecognized devices on the driver wizard. Again, it's not too common, but just for example, if you open the wizard and you can't find your device here, the first thing I would recommend to do is look for it in the LSPCI or LSUSB on Linux and find it there. If it is not there, then Linux does not recognize the device. It means that something is wrong. Maybe it is not fit properly in the slot. Maybe the firmware is not set correctly, so Linux can't access it and it's not recognizing it. In this case, I would recommend opening the D message and follow the boot sequence and see what the log says in this particular device loading. And if it is there, then we would recommend to utilize the PCI/UT direct tool, as I said, working sample, and see if you can access it. In any case, we would recommend to log with the WD debug GUI and the dmessage logs because it is proper kernel mode communication. So in order to see what's going on there, both of these tools would be most beneficial. The WD debug GUI specifically for when opening the wizard, because we can see the opening of devices in this log, and we can see maybe if something is going south when opening this specific device. Okay, now we got to the interesting cases. These are true cases, okay, that we got from clients. In this case, it's a PCIe device on an FPGA with several interrupt sources. The client states that there are no interrupt logs in the log. What happened is that the client has its device, it sets the interrupts on the device itself, but he can't see the logs in the log. He says, he is asking what went wrong because I can't see the logs. Now, is it the problem with the logs or the problem with the code of enabling the interrupt, or the problem is in the card? We don't know, but as I said, we need to start eliminating. So in order for everything to work well, we have the draw here, the scheme. So he loaded the firmware and enabled the interrupt. And as I said, we asked for logs in order to see what went wrong there. And then we see that he got an error in the transfer command, okay? And it said it pretty straightforwardly. The memory address was out of range. So something in defining the registry went well. And due to a malformed transfer command, the interrupt was not enabled. So the transfer command actually caused the issue, and the interrupt was not enabled in the first place, and no logs were shown by the interrupt. And it was relatively easy to find and to fix because it was a code issue and we didn't need to send him to redevelop his firmware. So this is just one example of, we opened the logs and we saw the issue there, and it was pretty straightforward. This case was regarding a build issue, and I will say in advance, talk to us if you are going to do what I'm going to say, because it involves changing our source code. The client was trying to compile a WinDriver generated code on an old Linux kernel version. We know that upgrading and updating the kernel version can be a headache because it requires a lot of changes all along the production line. And a lot of times clients are working with all the kernel versions. So the client sent us this log from the make, and we can see here we had a fault, WinDriver VMA fault. We looked on our source code and found what this error indicates. This error pops up when the Linux kernel version is, let's say, smaller or older than 4.11, which is what the client uses. Hence, he got the error pops up. What we recommend to do is, first of all, upgrade the kernel version because it has a lot of benefits. But if this is not something they can consider, we ask them to modify the the WinDriver source code, so it will be compatible with their kernel version conditions, and it will not block the build. Again, if you are going for that solution, talk to us before, because any change in the source code can break something else. So ask us, not for permission, but for possible consequences. Okay, so in this case, we had two different operating systems. The project runs on both Linux and Windows, and the Windows device and driver runs with no issues, but they weren't able to open the device on Linux. So when we look at the steps along the way, we say, okay, we have a device and a firmware, and it works on Windows, and they were able to open the device and make everything they wanted to do, but it's not working on Linux. So there's probably an issue on Linux. This is what we thought at the beginning. We asked for the D message for the Linux kernel debugger, and we saw this print, PCI can't change power state from this we call to D0. Config space inaccessible. We didn't understood too much what's the issue there, because again, we're not experts to Linux, but for troubleshooting WinDriver, so we didn't assume in the first place that it will affect WinDriver. We didn't understand why what went wrong there. So what we asked for is the logs from both Windows and Linux. And we diff and regress them. This is using Notepad++, but as I said, you can do it also via VS Code on Linux. And what we saw is that, first of all, the Linux logs are filled with errors. Unknown PCI header type, you see for a few lines here. But what we also saw, and we know that the header types are sitting in the configuration space. So there was obviously an issue with the configuration space that sits on the firmware. It sits on the card itself. This is not something that you can change with WinDriver or modify with WinDriver. It was malformed, the firmware. What we also saw is that the process didn't went smooth with Windows as well. Okay, they had all translated bus address failed. With the same time, with the same operation that took place on Linux. The thing is with Windows is that there was a fallback that took place due to different operation or different logic between these two operating systems, and the fallback allowed the process to continue without stopping. But it doesn't say that it would work on any platform after the distribution. So what happened here is that we spotted an issue on the firmware that could have caused a lot of headache and trouble after the distribution, because it works here, but maybe after on another computer, distributed computer with a different Windows version, it would not work because of this issue. So we actually found an issue on the firmware, okay, and we recommended to the client to update it and to modify it according to the header types convention, so he will not have issues while distributing. So again, the header types were unknown, therefore the Linux and WinDriver could not access the configuration space. Again, interesting case, and it involves a lot of moving parts as well. This is not a case study, more of, let's say, a heads up, because WinDriver, when clients upgrade WinDriver version, they need to follow a few steps that are elaborated in chapter 2.3 of WinDriver documentation. We always recommend on removing previous installations, because sometimes there is the collision in the kernel modules, both on Windows and from Linux, and removing previous installations will guarantee a smooth installation of the recent version. Again, loading the latest kernel module of WinDriver or your rename driver, because if you name the drivers the same, it can cause conflict and errors and confusion that really brings with them a lot of complexities. Licenses updated, as I mentioned, WinDriver license is bound to a specific version, WinDriver version, also for registration code, also for bitbit, but also for WinDriver version. So WinDriver 15 will not work on, license will not work on version 16 license. This is why it is important to update the license everywhere it needs, on the wizard itself, on the distributed app code. And if that doesn't happen, the app simply won't work. So this is another thing to be in mind for when upgrading the version. And as I said, generate code with the new version. If you have an app that you built with WinDriver 14.5 and you upgrade to 16.2, make sure to paste the code or move the code to a version 16.2 generated code, because it includes the includes and header tags and dependencies for this particular version. So no shortcuts when upgrading a WinDriver version. can save you a lot of time and headache in the future when distributing or developing. And if you encounter issues, then troubleshoot with different regress between versions, like we have shown before between the operating systems, and it can be a very insightful experience. So you can find bugs and issues on your app or process. That's it. I want to thank you for listening and joining this session. This is my email. Feel free to send me messages if you have any questions or requests. And this is our sales team email. If you are not familiar with WinDriver, you want to evaluate, you have questions regarding the pricing, regarding anything related to the product on the business side, you may as well contact them, and they will be happy to advise. So thank you again, and have a great evening or day wherever you are.
Thanks a lot, Daniel.
Thank you, Daniel.